For question number 1b, firstly we need to find the general equation of the triangle and rectangular. After that, we can use the table method, which we separate each of the function and we find the value for each function from the range of t. For example, I take t less than -1 and every function would have a 0 value. But when t is between -1 and 0, function u t plus 1 will become 1. And we total up each value of the function. After that, we can plot the graph according to the range of t. For convolution part, we need to know the general formula of the convolution, which is the integration from -infinity to infinity x1 tau times x2 t minus tau. So in this question, I choose x2 t to become x2 tau and x1 t to become xt minus tau. And we just substitute the t with tau. And for x1 t, we first substitute it to negative tau, and then we substitute it again, t minus tau. To find the equation of the triangle, we can use the quadratic formula, which is y equals to mx plus c, and then we get the equation. Next, we plot both of the graphs on the same plane, and we do for t less than -1, so there's no intersection between the two graphs, thus yt equals to 0. For t between -1 and 0, there's an intersection which is between -1 to t, and we integrate this part only, which is the limit -1 to t, and the equation of the line of the triangle times with the equation of this rectangle, which is -2 tau plus 2t times 1, and we got the value of yt, which is t squared plus 2t plus 1. And for t between 0 and 1, there's an intersection from -1 to t, but we need to keep in mind the equation of the triangle is not the same for the left side and the right side. Thus, we integrate one by one from -1 to t minus 1, and we take the equation of the left hand side, and from t minus 1 to t, we take the equation of line from the right side, and we integrate it like usual, and we get -t squared plus 2t plus 1. For t between 1 and 2, we can see that there's intersection from t minus 2 until 1, and we need to separate the integration to 2, which is from t minus 2 until t minus 1, and we take the equation of this left hand side, and from t minus 1 to 1, and we take the equation of the right hand side, and we integrate it till we get yt equals to -t squared plus 2t plus 1. For t between 2 and 3, we can see that there's only one intersection, which is t minus 2 until 1, and it's only on the left side of the triangle, so we can integrate like usual, and we get yt equals to t squared minus 6t plus 9. And for the last range, which is t greater than 3, we can see there's no intersection, thus yt equals to 0. Then we can summarize our calculation into this form to draw the graph, and the result is this graph.
Okay, so good day, I'm Thursday. So now I'm going to discuss the task which I have done, which is task 1, the MATLAB code. So firstly, I define the time vector first, which is t equals to -3 to n, and it ends at 3 with a unit step of 0.01. And after that, I declare a signal x1t, and it is a triangle signal. So to construct a triangle signal, I use the equation 2 minus 2 absolute t minus 1. Because the triangle signal has a changing point at t equals to 1, and also I set the values outside the -1 to 1 to become 0. So I declare like that. And after that, I construct signal x2t, which is a rectangular signal. So the rectangular signal has a width of 2. So therefore, at this width over 2, which is -1 to 1, the rectangle signal will become 1, and outside of this range, it is all zeros. So I declare that, and after that, I plot the two signals inside the same patch. So I use subplot function, and then I declare the title, x level, and y level. So same to the x2t. So after plotting the x1t and x2t, I calculate the addition of the signals. So I use zt to make it become the addition of my signals, and it will become x1t plus x2t lah. So just use the addition operation, and I plot the addition of the signal separately, and I label the title and also x label and y label. And after that, I also calculate the convolution of signals using this convolution function, and I insert x1t and x2t to do the convolution operation, and I make it SAM. The SAM is to have the same length as input lah. So because we want the vector to be the same length, so I scale it by time step, which is 0.01 lah, because here I use 0.01. So next I plot the signal graph, convolution signal graph, and I label it with my title and also x label and y label. So let's run to see the final result. So you can see that this is the x1t and x2t that is in the same patch. Okay, so it is triangle signal, rectangle signal, and square signal, and also this addition of the signal, which is x1t plus x2t, as you can see. And lastly, this is the convolution signal graph as short. Okay, so I think that is all from.
Afternoon, doctor. My name is Yu Gladys Kim from Group 1. My role in this assignment is doing the calculation parts of task 2. According to the equation of convolutions, we know that yt is equal to the integration of f tau product with ht minus tau, while yt is our output. First, we use the sine graph, which is 1.5 sine pi t product with our rectangular graph. So we can get ft, and we change the t-axis into tau axis and get f tau graph. Next, we need to obtain a graph of ht minus tau. So we use h1t minus with h2t. h1t is a rectangular graph with 1.5 amplitude, and its time is 0 and 1.5, while h2t is its amplitude is 1 and the time is 2 and 2.5. So we can obtain ht while using h1t minus with h2t. Next, we need to find h minus tau. So we change our ht graph from t-axis into tau axis and inverse it, so we can get h minus tau. Next, we use time shifting to get ht minus tau, so we can get the time, the tau axis is t minus 1.5, t minus 2, and t minus 2.5. Next, we start our calculations with different case. Case 1 is t lesser than 0 seconds, and we can get the integrations is equal to 0. Next is case 2. The time interval is between 0 and 1, so we can calculate our yt using integrations between t and 0. So we can get 1.5 square divide pi and product with 1 minus cos pi t. Next is case 3. The time interval is between 1 and 1.5, and we can get the overlap graph is between 1 and 0. So we can also use the integrations to find our yt. So it is 9 over 2 pi. Next is case 4. So we can see that our ht minus tau graph is always shift towards right, and we can get the overlap graph is between 1 and t minus 1.5. We also get the yt by using the integration formula. Next is case 5. Case 5, the time interval is between 2 and 2.5. And we also can get our integrations, and we can see the overlap graph is between 1 and t minus 1.5, and the other is between t minus 2 and 0. So we also can get our output. Next is case 6. So we can our ht minus tau graph is always to shift towards the right, and we saw the graph, the overlap graph is between t minus 2 and t minus 2.5. And case 7 is the time interval is between 3 and 3.5, and we can also get our integrations between 1 and t minus 2.5, and we get 1.5 divided by pi and product with minus 1 minus cos pi t minus 2.5. And case 7 is t larger than 3.5 seconds, and we can show that the graph doesn't have any overlap, so our integration is obtained 0. Okay, so according to different case, we can get our YT equations. According to these equations, to draw our graph, we can get this overall graph. And we check our graph with the decimals, we can observe that it is same. Thank you, Doctor.
Good afternoon. My name is Kan Yu Heng and I am from Group 1. I am doing the part for Task 2 MATLAB code. So here is our MATLAB code. So from the start, we set the t time from 0 to 3 with the interval 0.001. And for the input signal for our question is like this. So we code here. The heavy side is meaning unit step function. So we code like this according to the question. And for the LTI system, also we follow the question given. Then we follow the same code here, and we will get the result. So for the convolution is yt equal to ft times hash t. So we will get xt1 is for our ft and xt2 is for our hash t. So we multiply it like this. We put like this the code for convolution. Then for the convolution result, after we get the calculation, we'll get the range. The range is we'll put here for the axis. So this is the axis. So put here, then we run. So this is our final graph for the task 2. So let's now look for the animation. So here we can have a look for the animation. Okay, all the things I had explained through the comment, so we can have a look. Now we run. Let's see the animation. So here, get the animation. Alright, that's all. Okay, that's the animation. So that's all for me. Thank you.